Let's fill in some blanks. To and fro movement of an object is also known as. Here we have a pendulum clock. And if you see the pendulum of the clock, it is moving back and forth, to and fro. And such type of motion is called as oscillatory motion. Moving on to the next question. The noise becomes physically painful above. Let's see some examples to understand this question. Now, first of all, we have an example of rustling of leaves. You can hear that it is actually very soothing. And on the decibel meter, it shows only 20 decibels. That is the reason it is absolutely soothing to the ear. Next example is of moderate rainfall. And yes, we do love rainfall, right? The smell of petrichor. So now, on the decibel meter, it shows 50 decibels. Still soothing to the ear. The next example is the example of alarm clock. Oh God! It's irritating, right? That means here it has become physically painful to us. On the decibel meter, it shows 80 decibels. Now obviously, above that we have the hair dryer. Hair dryer is 90 decibels. Again irritating to the ear. Car horn, 110 decibels. Then we have jet plane, oh God, 120 decibels. And here we have fireworks, which is 140 decibels. So here you saw that above 80 decibel, sound was physically painful, right? It was irritating to us. So the correct answer over here is above 80 decibels. Moving on to the next question. Dash of sound depends on amplitude of vibration, right? So let's try and relate them. So first of all, we have a speaker with us and we have equidistant layers of air. Now, as soon as we turn the speaker on, you can see that the particles start to vibrate and thereby energy is transferred from one point to the other. Now, when the particle moves, it displaces by a certain value and the maximum displacement is called as the amplitude. So, if we plot a graph of this longitudinal wave, we obtain a waveform something like this, which looks like a transverse wave, but it is not a transverse wave. It is just the representation of a longitudinal wave. And what is the maximum displacement called? It is called as the amplitude. Now, what we are going to do is, we are going to increase the amplitude. So as you increase the amplitude, you saw that the loudness of the sound also increased. So, dash of sound depends on the amplitude of vibration. Loudness of sound depends on the amplitude of vibration. When you increase the amplitude, loudness also increases. When you decrease the amplitude, loudness also decreases. Next question. Speed of the light is dash then the speed of sound. Let's go there and try to understand. You just saw that we were able to see the lightning first, and after some time we were able to hear the sound, hear the thunder, right? That means speed of the light is more than the speed of sound. So the answer over here is more. Now moving on to the next one. A high-pitched sound has dash frequency. Now we have already seen this. We have a man and a woman. Now a high-pitched sound. We know high-pitched sound are shrill sound. For example, when a man speaks,
oh, hello,
you can see that when he said hello, it has certain number of waves created. When a woman speaks, hello, you can see that the number of waves created are more. That means here the frequency is more, here the frequency is less. So a high-pitched sound will have higher frequency and a low-pitched sound will have lower frequency. So answer over here is high frequency.